Preparing litholog is an important exercise in stratigraphy and in stratigraphic correlations. Let us try to understand in simple cases how the lithologs are to be prepared. What is a litholog? It is a stacked up pattern of lithologies presented on a paper in a graphic way. Let us take the example of a prototype or a natural case where the lithological contacts are horizontal. A, B, C are the horizontal lithologies. Measure the different thicknesses and then use a suitable scale to convert these so many meters, suppose in the field, into so many centimeters in a graphic presentation. For example, in the field I choose 1 meter distance will be equivalent to 2 centimeter in my sketch. The scale is to be chosen in a way that all the units are presented properly. They should not be very thin that they are not visible. We should not choose a scale in such a way that the unit A, B, C and possibly D, E whatever are there goes outside the paper while drawing. So, the choice of scale becomes important. We take now a case of units P, Q and R. Their lithological contacts are all dipping in the right hand side. Imagine all of the lithological contacts are making theta angle as the dip. So, we are essentially dealing with homocline in this case. How to present the homoclinal data into a litholog? Let us start with layer P. So, I have drawn separately layer P, theta is the dip. Suppose layer PQR and their contacts are dipping towards x degree geographic direction, which can be north, south or northeast or northeast or let us say 20 degree north, which can be measured using a clinometer or Brunton in the field. And along that same geographic direction I have drawn a horizontal line. This is a special case. After this special case is discussed, we will also see more general cases. So, I mean here that this horizontal line is having a trend same as x degree. Trend is equal to same as that of the PQ, QR contacts trends. Now, if omega is the orthogonal thickness of layer P, I write here small a, small b and small c, and a right angle triangle is considered. Since omega is orthogonal thickness, so this angle has to be 90 degree. So, within triangle ABC I can write sin theta is equal to omega divided by h horizontal thickness. So, from here I can say omega equal to h sin theta. So, in the field if theta is measured using clinometer or Brunton and h is measured, suppose along that specific line this much of thickness is measured by a tape, or a geologist walks from here to there and he knows his one step is equal to so many centimeter, then that can be converted to h value. From h and theta known, omega can be obtained. This is the omega. You can ask a question, why not measure this omega thickness directly in the field? It is not always possible. Suppose here you have an axis, you are standing and you want to put a tape along this direction, but at this point you cannot reach because it is a hilly area. Not always you will be able to come over here and measure. So, in this way this h is obtained. Now, this h1 can be obtained for layer Q and h2 can be obtained for layer R. From there we can find omega, omega 1 and omega 2 amounts. Now, those will be plotted using a suitable scale in a graphic way as omega, omega 1 and omega 2. So, these are the orthogonal thicknesses, as if layer PQR were horizontal first and then they got tilted. When it was horizontal, this would be the presentation. Along with the litholog, we sometimes put the biostratigraphic data, the fossil information can be provided in the caption of such lithologs. certain lithologies have almost standard symbols to be presented. So, looking at the book you can find out, say let us say for granite what kind of symbol, for conglomerate circles, and for sandstone it can be dots, shells can be shown by shades. Now, let us take our equation omega equal to h sin theta and take a specific case of theta 90 degree, which means the lithological contact is vertical, such as drawn over here. So, in this case if I put theta is equal to 90 degree, sin 90 is equal to 1, which means omega becomes h. Now, this looks logical from the diagram. Omega, the orthogonal thickness, has become equal to h, which means this deduction what we made looks correct. We are now going to see a more general case when we are dealing with a homocline as usual, P, Q and R, but this time the apparent thickness of the units have been measured along a line, and this line has a trend y degree, whereas the dip direction of P Q contact and Q R contact is z degree and y is not equal to z. Here we are going to involve Stereonet and solve it. Now, we are taking a general problem of finding out the orthogonal thickness of layers, say layer P, Q, T and B, that will be useful in plotting the litholog. Let us consider that the lithological contact, where are the lithological contacts between B and P is this one, between P and Q is this one, and between Q and T is this contact. Consider we are dealing with parallel contacts, and these litho contacts strike 30 degree, 210 degree. We are referring to these angles measured with respect to north in a clockwise direction, which is the conventional way. Consider that these lithological contacts dip 40 degree and the dip direction of these three litho contacts are 120 degree. Note that 30 degree plus 180 degree is equal to 210 degree, which is written over here, and 30 degree strike plus 90 degree is equal to 120 degree, which is the dip direction written over there. Since the litho contacts have same strike, same dip and same dip direction, that means we are dealing with parallel litho contact case. Now, consider along a line L, I have not yet drawn there, the thickness of P unit is 20 meter. Suppose in the field we got an opportunity to measure the thickness of the layer P, and the thickness is 20 meter, but the line L has a plunge 60 degree and trend 150 degree. Now, the question is, for layer P, how much is the orthogonal thickness? If we can solve this for layer P, then for layer Q also we can solve similarly. We will approach this problem using Stereonet. So, I have taken a Lambert equal area projection, I have taken a tracing sheet and I have drawn the peripheral circle. I have marked the north, which is 0 degree, south which is 180 degree, east which is 90 degree and west which is 270 degree. I have also marked the center. So, our first job will be to plot the lithological contact from the strike dip direction data. It is 30 degree, 210 degree strike. So, first I plot 30 degree, 10, 20, 30 and 210 degrees, 180 here, 190, 200 and 210. What I have plotted? I have plotted the strike of the litho contact. Next, the dip direction is given 120 degree. I have to plot 120 here. This is 90 degree or east. So, from here 100, 110 and 120 degree, and this is the dip direction. So, I have utilized the strike data and the dip direction data. Now, I have to plot the dip information 40 degree to draw the great circle. To do that, I maintain the center drawn in the tracing sheet over here, same as the Stereonet which is lying below this one, and rotate so that this 120 degree dip direction goes with the east of the Stereonet. Ideally, one can put a pin over here and rotate, but without that also we can rotate and then match the center. So, I have rotated and I have brought this 120 degree with the east. Now, from here and towards the center, I have to move amount same as the dip amount, which is 40, 10, 20, 30 and 40 degree. So, this angle is 40 degree. I am doing slowly so that students can follow. I can do fast, but that will not help the students. Now, what I do, from this strike point which is 30 degree and the strike here 210 degree as a point, and this dip, I have to draw a great circle which passes through this point and that point, and I can see this great circle. So, which I draw. Do not draw too fast, then it will be inaccurate. Do not draw too slowly, then it will take long time. So, I am following a mid path. I am drawing not too fast, not too slow. Now, if I move back, match 0 degree with the 0 degree of the Stereonet, a great circle is drawn, and this great circle represents the lithological contacts which are parallel. Now, we are going to plot the line L, and the data is plunge 60, trend 150. I am going to first use the trend data 150. This is 90 and this is 120, this is 130, 140 and this is 150. So, this is trend of L line. Trend is plotted. Now, I am going to use the plunge. The plunge I said is 60 degree. To use the plunge data, first of all, I will bring this point at the south of the Stereonet, maintaining the center to be same. So, I rotate the tracing sheet. I am doing without a pin. So, after rotating, I adjust the center, superpose the center in the tracing sheet with the center in the Stereonet, and now from here I will move inside 60 degree angle, which is the plunge amount 10, 20, 30, 40, 50 and 60. So, this amount is 60 degree, and doing this point actually represents the stereographic projection of the line. So, here is the line. So, what we have got? We have got the great circle representing lithological contact, and the line along which the thickness has been measured. The thickness data is given, and there is no way, and it is not required either, to think that we will plot the thickness in the Stereonet. That is not possible. In Stereonet, in tracing sheet, we can plot planes and lines, but the thickness data cannot be brought over here. We will now do one more thing. We will draw the pole of this plane. The lithological contact. This we are going to plot. So, how to do that? I have rotated the tracing sheet, maintaining the center, superposing with the center of the Stereonet. The dip direction is brought over east region, and this is the plane after moving the tracing sheet Now from this point I will move 90 degree inside, 10, 20, 30, 40, 50, 60, 70, 80 and 90 degree. So I can, for the beginners, write down that this angle is 90 degree, and what we have got, this is the pole of the given plane. So I can call it as P for pole. Next we need to find out the acute angle between the pole and the line. Pole is a line which is perpendicular to the plane, and line is there. Their acute angle we need to find out. I will explain later why these steps were required. To find out the acute angle between P and L, I have to draw a great circle passing through P and L first of all. To do that, I have to keep rotating the tracing sheet, maintaining the center to be the same, and look for an opportunity when I can draw a great circle passing through P and L. And after trial and error and some rotation, I can see P and L has fallen on a single great circle that I am going to draw now. Why I am doing this is required to find out the angle between P and L. So this red great circle represents a plane on which P and L lie. To find out the angle, I have to measure this angle and check whether this is acute angle. Let us try 10, 20, 30, 40, 50, 60 and 70 degree, which is the acute angle. What is the other angle? The other angle will be between two lines. If one of the angle is 70 degree, the other angle will be 180 degree minus 70 degree, which is 110 degree. So this is the angle between P and L. This is the acute angle that we were looking for. By the way, where is this 110 degree angle? That also I will show. This angle we have said 70 degree. We want to measure this angle plus this angle, and if we do that 10, 20, 30, 40, 50 degree here, and here it is how much? 10, 20, 30, 40, 50 and 60 degree. 60 degree plus 50 degree is 110 degree. Okay. So we have obtained the angle between the pole of the lithological contact and the line. What is this line? This is the line along which we found the apparent thickness of the lithology P. Now we are going to use this 70 degree angle and draw triangle ABC. Think three dimensionally. This AB length, let us say it is the orthogonal thickness or the true thickness, then this AB line must be represented by the pole, because by definition pole is a line which is perpendicular to the plane, and the line in space AC, which is our line L length, has a length of 20 meter given, and the angle we know that their angle is 70 degree. So we want to know the AB length is how much within the triangle ABC, where angle ABC is equal to 90 degree, angle BAC is 70 degree. I understand this drawing is not as per that, this is certainly less than 70, so I am writing not to scale an angle. Consider this is 70 degree, then we can write cos 70 degree is equal to this AB length divided by 20 meter, that is what I am writing. So the AB length will be cos 70 multiplied by 20, whatever comes out, and that is in meter, and this is the answer. This is the of the lithological contact. Once in this way we find out the thickness of layer P, the true thickness, we can also find the other layers, and eventually we can construct a lithological log consisting of B, P, Q and T. So, in this way, using the Stereonet, the basic stratigraphic problem, presentation of the lithological layered rocks can be made in a graphical way.